my dear children. Welcome to the mathematics class. Today we are going to discuss triangles. In this chapter, we are going to discuss the concepts of exercise 7.2. Okay, my dear children. In the previous class, we have discussed the sums in the exercise 7.1. I hope you have learned, you understood, and you have learnt well the exercise 7.1 concepts as well sums in the exercise 7.1. Okay, my children. Now come to the concepts of exercise 7.2. Are you ready to listen the class? Right. In the previous exercise, we have studied two criteria, two rules of congruence of triangles. Okay, my children, we have studied two rules or two criteria for congruence of triangles. Now let us now apply these results to study some properties related to a triangle whose two sides are equal. Okay, my children, right. Now come to this point. Some properties of a triangle. In earlier class, you have studied the classification of triangles based on lengths of sides of a triangle. Do you remember that classification, my children? Yes. Equilateral triangle, isosceles triangle, and scalene triangle. These are the types of triangles based on the lengths of the sides. Classification of triangles based on lengths of sides. Okay, my children. Out of which isosceles triangle. What is meant by isosceles triangle? Come to this point. Let us recall that definition. Isosceles triangle means a triangle in which two sides are equal is called an isosceles triangle. Do you remember this point, my children? Do you remember this definition of an isosceles triangle? Right. Now come to some examples. To understand this point well, let us take some examples. See, in this triangle ABC, here AB is 7 centimeters, BC length is 7 centimeters, and CA length is 9 centimeters. So if you observe these sides, here AB equal to BC. So this is called an isosceles triangle. This is an example for an isosceles triangle. Come to the second example, triangle PQR. In this triangle PQR, PQ length is 3.5 centimeters, QR length is 8 centimeters, and PR length is 8 centimeters. By observing the lengths of these three sides, these two sides are of equal length. Isn't it or not, my children? Right. Therefore, this triangle is also an example for an isosceles triangle. Now come to the third example. See this figure, triangle DEF. In this figure, they have not given the measurements of the triangle, measurements of the sides of the triangle, but they are marked by the same. See here, this and this side and this DE side and EF side are marked by this one line. Means they are equal sides. They are of equal length. Understood this point, my children? Here the measurements of these sides are not given, but by observing this figure, DE length and EF length are equal. Okay, my children, understood this point? Right. Similarly, come to this triangle. This was also an example for an isosceles triangle. Understood this point, my children? Right. Come to the figure 4. XYZ, triangle XYZ. In this triangle also, measurements of the sides are not given, but two sides XY and XZ, these two sides are marked by the same line. Isn't it or not, my children? See here, small line. So these two sides are of equal length. Understood this point, my children? So this triangle is also an example for an isosceles triangle. Similarly, come to the fifth example, triangle GHI. In this triangle, this side GI and in this triangle GHI, side GI and side HI, they are marked by the same line. See here, observe this part, my children. So these two sides are of equal length. So this is also an example for an isosceles triangle. Understood this point, my children? Right. Now come to the theorem number 7.2. Angles opposite to equal sides of an isosceles triangle are equal. Okay, my children. This theorem statement is angles opposite to equal sides of an isosceles triangle are equal. We use this theorem in solving the sums in the exercise 7.2. Okay, my children. Please understand this point. Understand the statement of this theorem 7.2 well. Okay, my children. Right. So to understand this theorem statement well, I am taking some example. See this example in triangle ABC. In triangle ABC, which sides are equal? AB and BC are equal. So I wrote here AB is equal to BC. Implies, see here AB. In this triangle ABC, two letters are taken here. Which letter is missing here? So we have to take angle C. Understood, my children? Keep here is equal to as it is equal to. Here BC is there. Which letter is missing here? Angle A. So right angle A. Understood this point, my children? This is small technique. If the two sides are equal, without observing the which angle is opposite to which side, without confusion, it is a small technique. Otherwise, you have to observe the figure, which angle is opposite to the side. Okay, my children. So for this side AB, opposite angle is angle C. Similarly, for BC, opposite angle is angle A. So angle C is equal to angle A. Understood this point, my children? Is it clear? Right. Come to the second example. In triangle PQR, PQ is equal to PR. The two sides are equal. Then what is the angle opposite to this side PQ? Angle R. So angle R is equal to, what is the angle opposite to this side PR? Angle Q. So angle Q. Angle R is equal to angle Q. Otherwise, same technique. You can use here same technique. Here PQ is equal to PR implies here two letters were used, P and Q. Which letter is missing here? Angle R. So R, angle R is equal to, here two letters were used, PR. Which letter missing here? Q. So angle Q. So angle R is equal to angle Q. Understood this point, my children? Right. Now come to the third figure. In triangle DEF, EF and DF, these two sides are equal. Then which angles are equal in this triangle? Yes, see here DEF is there. So letter D is missing. So angle D is equal to, here which letter is missing here? E. So angle E. So angle D is equal to angle E. Is it clear, my children? Right. Similarly, in triangle XYZ, XY and YZ, these two sides are equal. XY is equal to YZ. Then this implies XY letters were there. Which letter is missing here? Z. So angle Z is equal to, here YZ, two letters YZ are given. Which letter is missing? X. So angle X. So angle Z is equal to angle X. Otherwise, we have to observe the figure and we have to identify the angle opposite to that particular side. Okay, my children, is it clear? Right. Now come to the theorem 7.3. Okay, my children, the sides opposite to equal angles of a triangle are equal. This is just converse of the theorem 7.2. Okay, my children, for these two theorems, proofs no needed. In the examination point of view, they will not ask in the exam, prove that, like this they will not ask. Okay, my children, that is why I am not explaining the proof of theorem 7.2 and theorem 7.3. Okay, my children, only statements are enough. by using the statements. We solve the sums in the exercise 7.3. So what is the statement of theorem 7.3? The sides opposite to equal angles of a triangle are equal. Okay, my children, to understand this theorem well, let us take example. In triangle ABC, see here angle B is equal to 70 degrees, angle C is equal to 70 degrees. These two angles are equal. Then what are the sides opposite to these two angles? What is the side opposite to angle B? AC. AC is equal to, what is the side opposite to angle C? AB. So AB. Understood this point, my children? So by observing the figure, we can write this statement. Otherwise, a small technique, angle B is equal to angle C. This implies B, the letter B is the given. Which letters are missing? AC. So we wrote AC. Understood this point, my children? Right. Is equal to angle C. C, letter C is given. Which letters are missing? AB. So write AB. So side AC is equal to side AB. Understood this point, my children? Is it clear? Right. Similarly, see the second example. In triangle PQR, angle P is equal to angle Q. What is the side opposite to angle P? This is QR. The side opposite to angle P is QR. So QR is equal to, what is the side opposite to angle Q? PR. So QR is equal to PR. Otherwise, angle P is equal to angle Q implies, how can you write with respect to sides? Here letter P is given. Which letters are missing? QR. So QR is equal to, here Q, letter Q is given. Which letters are missing? PR. So QR is equal to PR. We can write like this also. Okay, my children, is it clear? Right. Now come to the third example. In triangle XYZ, angle X and angle Z are equal. These two angles are equal. Then what is the side opposite to angle X? YZ. So YZ is equal to, what is the side opposite to angle Z? XY. So YZ is equal to XY. These two sides are equal. Understood this point, my children? Right. Using this theorem 7.2 and 7.3 and previous knowledge, we solve the sums in the exercise 7.2. Okay, my dear children, these are only the concepts of exercise 7.2. Okay, my dear children? Right. Now come to the sums in the exercise 7.2, my dear children. Page number 123 in the textbook. Okay, my dear children, come to the question number 1. First question. In an isosceles triangle ABC, with AB is equal to AC, the bisectors of angle B and angle C intersect each other at O. Okay, my children, understood this point. Join A to O. Show that first part OB is equal to OC and second part AO bisects angle A. Here two parts are there. We have to prove that these two parts. So according to the question, let us draw a triangle. Triangle ABC. What is given? AB is equal to AC. AB is equal to AC. So here I have written. Come to the solution part, my children. In the adjacent figure, given triangle ABC is an isosceles triangle, and also given that AB is equal to AC. Immediately, what can you write here? By theorem 7.1, the angles opposite to equal sides are equal. Okay, my children. What is the angle opposite to side AB? Angle C. Angle C. Angle C. Isn't it or not, my children? Or angle C or angle ACB. Or angle ACB. Okay, my children. Right. What is equal to AC? What is the angle opposite to side AC? Angle B. So angle ABC. Angles opposite to, because angles opposite to equal sides of a triangle. Because angles opposite to equal sides of a triangle are equal. By using this property, we have written this statement. Understood this statement, children? Right. Now, what is given? The bisectors of angle B and angle C. So, here these two angles are equal. Angle B is equal to angle C, or angle ABC is equal to angle ACB. Okay, my children. So, bisector of okay, my children, let us assume this is bisector of BX is the bisector of angle ABC, and CY is a bisector of angle C. So let us assume that BX is bisector of angle ABC, and CY is the bisector of angle ACB, and BX and CY are intersecting at O, and BX and CY and they are intersecting at O. Understood this point, my dear children? Right. So here OB and OC are bisectors of angle B and angle C. Isn't it or not, my dear children? Right. So automatically this upper angle is equal to the lower angle. Isn't it or not, my dear children? So therefore, how can you write angle ABO, angle ABO is equal to angle OBC. Isn't it or not, my children? Right. Similarly, angle OCB is equal to angle ACO. Angle ACO is equal to angle OCB. Understood this step, my children? This angle equal to this angle. Similarly, this angle is equal to this angle. Okay, my children? Understood? Right. So, what can you say about this figure? This angle is equal to this angle is equal to this angle is equal to this angle. Isn't it or not, my children? Right. So, angle ABO is equal to then angle ABO is equal to angle OBC is equal to angle BCO is equal to angle ACO. All these four angles are equal. This is 1, 2, 3, 4. All these four angles are equal. Okay, my children, understood this point? Right. What is given? Join A to O. Join A to O. So, in triangle OBC, this angle is equal to angle 2 is equal to angle 4. Isn't it, my children? In triangle OBC, in triangle OBC, angle OBC is equal to angle OBC equal to angle OCB, angle OCB or angle BCO. This implies in a triangle, if any two angles are equal, then the opposite sides are equal. The sides opposite to equal angles are equal. So what is the side opposite to this angle? Angle OBC. What is the side opposite to this angle? OC is equal to angle OCB. Angle OCB. Then what is the side opposite to this angle? OB. Understood this point, my children? Right. Let us assume that this result is 1. Okay, my children? Understood? Right. Now, let us compare OAB triangle, OAC triangle. In these two triangles, okay, my children, in triangle, so we have proved this one part, first part is over. In the second part, in triangle AOB or OAB, in triangle OAB, triangle OAC, these two triangles OAB, OAC. In these two triangles, okay, my children, OB is equal to OC. We have proved here. OC is equal to OB is equal to OC. We have proved from the equation 1 we can write OB is equal to OC. These two sides are equal. These two sides are equal. Similarly, angle OBA equal to angle OCA or angle ABO, angle ABO, angle ABO, angle ABO is equal to angle ACO, angle ACO. From this statement, see here, my dear children, observe this statement, angle ABO is equal to angle ACO in these two triangles. Okay, my dear children, right? These two angles are equal. These two angles are equal. Next, AB is equal to AC, already given. AB is equal to AC. It is already given. So, by side angle side congruence criteria, these two triangles are congruent triangles. Okay, my children. Therefore, triangle OAB is congruent to triangle OAC by SAS. Simply we can write by SAS rule. Okay, my children. Then automatically, what is the third angle? Angle OAB equal to angle OAC. Isn't it or not, my children? Angle O, this implies angle OAB is equal to angle OAC. So these two angles are equal. That means AO, this line AO bisects this entire angle A. This implies OA bisects angle BAC or angle A. So hence proved. Understood, my dear children? Right. Now come to the question number 2. Next question. Okay, my dear children. In triangle ABC, AD is the perpendicular bisector of BC. Okay, my dear children. Immediately you have to recall the knowledge. What is meant by perpendicular bisector? Okay, my dear children. Without knowing it, you can't solve this problem. Okay, my children, right? See the figure. Show that triangle ABC is an isosceles triangle in which AB is equal to AC. Right? Understood this question, my children? Right? Have you bring the knowledge of perpendicular bisector of a line segment? What is meant by perpendicular bisector of a line segment? A line which bisects means it divides the line segment into two equal parts, and it is that line is perpendicular to line. Okay, my children. So here AD is a perpendicular bisector, means this line AD is dividing the line segment BC into two equal parts, means BD is equal to DC. Understood this point, my children? And moreover, AD is perpendicular to BC. Okay, my children? Right. You have to remember these 2 points. Okay, my children? Right. Come to the solution part. In the adjacent figure, in triangle ABC, AD is a perpendicular bisector of BC. So, with the help of this statement, we can write it as AD is angle ADB, angle ADB is equal to angle ADC, that is 90 degrees, and BD is equal to DC. Isn't it or not, my children? This line AD is dividing this line segment BC into two equal parts, means BD is equal to DC. Okay, my children? Right. Now we have to prove that AB is equal to AC. Isn't it or not? Right. To prove this statement, let us take the triangle ADB, triangle ADP, and the triangle ADC. In triangle ADB, we are comparing the corresponding parts. So what I said, you have to draw the rough diagram of these two triangles ADB. See here ADB. Next to ADC in the same order. I told you clearly, when you are drawing rough diagram, you have to draw the vertices. You have to take the vertices in the same order. ADC. You have to take in the same order. ADB. So ADB. Next ADC. In these two triangles, we are comparing the corresponding parts. Okay, my children. Here AD is common side. Okay, my children. AD is equal to AD. This is a common side. Observe this figure, my children. This is a common side to these two triangles. Isn't it or not? Right. Next, BD is equal to DC. We have proved here. BD is equal to DC. We have proved. We have shown here with the help of this statement. BD is equal to DC. So AD and BD is equal to DC, or DB is equal to DC. Okay, my children. Angle ADB is equal to angle ADC. This is also proved here. Angle ADB is equal to angle ADC is equal to 90 degrees. So by observing these two triangles, two sides and included angle in this triangle are equal to the corresponding two sides and included angle in the second triangle. Isn't it or not, my children? Right. So what can you say about these two triangles? These two triangles are congruent. Therefore, triangle ADB is congruent to triangle ADC by SAS rule. Understood this step, my children? Right. So these two triangles are congruent, then automatically AB is equal to AC or not? Yes, by CPCT. This implies by CPCT. What is meant by CPCT? Yes, corresponding parts of congruent triangles. Okay, my children, do you remember this full form of these four letters? Corresponding parts of congruent triangles. So this line segment AB is equal to line segment AC. So in this triangle, this side equal to this side equal to this side. Then what can you say about this triangle ABC? Two sides are equal. Then triangle ABC is an isosceles triangle. Therefore, triangle ABC is an isosceles triangle. Isosceles triangle with AB is equal to AC. Hence proved. Understood, my children? Right.